Hello and welcome back to Neural Data Science. Today we're going to be learning about looping data files. So I'm going to go into my looping data files folder on CoCalc, open this Jupyter notebook, and the questions that we're addressing today are how can I efficiently read in many data sets from files? So far we've learned how to read a single data set or a single file into a Pandas data frame. But how can we read data across many files, and can we then combine that data into a single Pandas data frame? So our learning objectives are to be able to read and write globbing expressions that match sets of files, to use glob to create lists of files. Glob is a command you'll learn about. Write for loops to perform operations on files, and combine Pandas data frames. We can use a for loop to process files given a list of their names. Remember that a for loop allows us to do the same thing across many items in a collection, such as a list. So if we create a collection that is a list of file names, we can use a for loop to loop over those file names and run the pd.read_csv command on each file and load them in. So you can see an example here, and we'll type this out. So first we're going to import pandas as pd, pretty standard, so that we can use pandas. And then we're going to define a list called data files. And we're going to assign the values, so square brackets, to define a list. And both of these data files are in a subfolder called data. And so we're going to include data in the name of the first file, data slash tells us go into the data folder. And then the file itself is called gapminder_gdp_africa.csv. Close our quotes, so that's our first file name. Comma, next list item is the next file name, open quotes, data slash gapminder_gdp_asia.csv. So we have two files that we want to load. Next, we're going to write our for loop. So for file name in data_files, Jupyter indents the next line because this is the body of our for loop. And we're going to say data equals pd.read_csv and file name. So each time through, it will substitute file name for a different item from our list up above. And we're going to say index_call equals country. And remember that tells pandas which column in the CSV file we want to use as the index, so the row labels. So having read that file in, we are going to ask Python to print the file name, comma, data.min. All right, so we're going to open each file, and we're going to print out the name of that file and then the minimum value. And when we run min on an entire data frame in Pandas, we actually get out the minimum value in each column. So I'm going to run that, and you can see that what I get is the output first, the file name of the first file, GDP Africa, and then GDP per cap 1952, 298, 1957, 335, etc., etc. So for each of those columns, for each year, it's printing out the lowest GDP. We don't know which row, which country that was associated with, but that's not what we asked for. And then it does it for the Gapminder Asia data as well, in the same kind of output. All right, so that's in a nutshell how we would read a set of files and do something to each one. Another thing to know is that you don't necessarily have to know and explicitly type the names of all the files ahead of time. And this can be really useful because, for example, in the Gapminder dataset, we have data files for each continent. So that would be a lot of typing if we had to type them all in. Similarly, in an experiment, we might have data collected from a number of individual experimental participants. And each participant's data may be stored in a different file. And maybe we have 10 participants, maybe we have 100, maybe we have 1,000 participants. Obviously, you wouldn't want to hard code and type in 1,000 different file names. But if the files are named in a systematic way, so imagine in that experiment, we called our files S001, S002, S003, and so on, where 1, 2, and 3 were just anonymous identifiers for those subjects in the experiment. Then it's very easy to say I want all of the files that start with S and end in, say, .csv. This is how you do that in Python. You use a function called glob. Glob is actually a package Globbing is a term from Unix Linux systems that basically means matching a set of files with some sort of pattern. So we're going to import glob. We're going to import that package. And then as an example of running it, we're going to print out all CSV files in data directory. And to get that, we do glob.glob. So glob.glob sounds weird, but basically there's a glob package. And then within the package, once we've imported it, there's a function that's also called glob. So we glob. And we glob data /star.csv. So what we're saying is look in the data folder and return every file whose name ends in .csv. So the star there before the period means match any text, so any number of characters. Run that, and you can see what glob returns is a list, so it's in square brackets. And we've got data gapminder _all.csv, gapminder _gdp _asia.csv, data /s1.csv, so a lot of different files with different file names. So that wildcard, the star, matches anything, basically, and then anything that ends in .csv. We can get more specific, and we'll see an example of that in the next code here. Oh, and I'm going to add a code cell below so I can type in this code. So here I want to read in only the files that start with the text gapminder _, and then any text after that ending in .csv. So I'm going to say for file name in glob.glob, favorite command name ever, data /gapminder _star.csv, colon, so it's a for loop, data equals pd.read _csv, file name. So for each file that we find, read it, and we're going to again print out a bit of information about it. In this case, we're going to print the file name, and then data square bracket GDP per cap _1952. So we're going to specify that column, the 1952 column, .min. So I just want the minimum value from one of the columns, whereas in the last example, we got the minimum value from each column. Run that. There we go. We got each file, shows us the file name. They all start with gapminder _, they all end in .csv, and then we get the minimum GDP value from 1952. So far these examples have allowed us to read in a set of files and do something to each file, but we haven't actually combined the files yet, and that's a very common task. And it turns out that Pandas actually allows us to combine data frames in a lot of different ways. You can see here there's at least four different methods, I think there's more, that allow us to combine data frames. These include .concat, .merge, .append, and .join. There's reasons why you might want to use one or the other, but for now we're just going to work on the concat one because that will serve our needs, and it's easier than sort of going through all of them exhaustively and explaining all the subtleties of each. For now, you really just need to know one way of combining Pandas data frames, and concat is a nice, simple one to use. All right, so we're moving from the gapminder data set into some hypothetical, I actually just made up this data, reaction time data from a cognitive behavioral experiment. So let's say we have data from an experiment in which we ran 3 human participants, sometimes we call those people, on different days. For each participant, we have a data file. The columns and all the files are the same because the files were all generated by a computer program that ran the experiment. We give the participants anonymized ID codes to protect their privacy and allow for a simple systematic naming convention for the files. First participant's data is saved in a file called s1.csv, second is in s2.csv, etc., etc. And again, these are all in the data folder. So we can glob the data folder in which the files are stored, find all the CSV style files that start with an S, followed by a single character, followed by CSV. We can do this way, and we'll assign the output of that back to a variable, which we'll call file names. So file names equals glob.glob. So all this is familiar from the previous examples. One little difference, though, is we're going to say data /, and instead of saying s*.csv, we're going to say s ? 10.csv. So the question mark is kind of like the star in that it matches any text, any character, but a question mark matches a single character, whereas a star matches any number of characters. So in other words, this would match S1, S2, S3.csv, but it wouldn't match, say, S10.csv, because 10 is 2 characters between the S and the period. So if we wanted to match S10, we'd need S question mark, but that wouldn't match S1. So for now, this is fine. We only have 3 subjects, so our S1, S2, S3 naming convention makes sense. If we actually anticipated that we were going to have more than 9 participants, in order for our glob functions and our code to work well, we'd probably want to think that we want to name the first subject's data file S01, second one S02, so that way we can actually get up to S99 and always have the same number of characters in our file names. If we anticipated that we were going to have more than 99 subjects, we would actually probably want to use S001, S002. Again, just so that as long as your names for your files are very consistent in their structure and how many characters they are, then writing code to read them in later is much easier than if you were inconsistent in your naming structure. So I'm going to run this, and it doesn't say to in the example, but I'm just going to ask it to print file names to see what we got. And that's always good. You shouldn't assume that your code works. You should test that your code actually did what you thought it would do. All right, and indeed this prints out, it finds our 3 file names, S1, 2, and 3. One interesting thing about Glob is that it doesn't actually report the file names in alphabetical order. It doesn't sort them. Doesn't really matter, but you can see here we have S1, S3, S2. If for some reason you wanted to have them in alphabetical order, you could say something like print sorted file names, and then we'd print them in order. The list itself is still not in order, but we could also do something like, let's remove the sorted command from print. We could say file names equals file names and sorted file names. And now when we print it, they're sorted, but they're actually stored in order. But in general, it doesn't really matter for this sort of thing, because once the data is all in a data file, usually the sequence doesn't matter so much as just having all the data there. Okay, so we have our list of file names. We haven't actually read them in yet. And what's different from what we did before basically we read in each file, did a thing to it, and then essentially just dumped that data from memory, because when we read in the next file, we overwrote in memory. So I'm just going to scroll back up. Right, so each time through the loop, data equals a new file. It reads a new CSV file, stores that as a pandas data frame, does something to it, and then loops again. Of course, if we want all the data added together, we don't want to overwrite the data each time we read a new file. So what we're going to do is create a temporary hold-in list for all of the pandas data frames from the individual files that we read in. So we'll call this df_list equals empty list. Run that, and there we go. And now we're going to say for f in file names, df_list.append, so that's the .append method for lists. pd.read CSV f. Run that, and then let's see what's in our df list. Oops. And here it is. So you can see the square brackets at the start of the list, square brackets at the end. And then the first entry in the list is a pandas data frame with participant ID, which is S1 in all rows of that column, a trial column, which goes from 1 to 10, and then an RT column, which actually contains the reaction times. At the bottom of that 10-row data frame, there's a comma, so that's one list item. Next item in this df list is the next data frame. So we have a list of data frames. Remember that lists can contain virtually any Python data type. So pandas data frames are a Python data type. So we can build a list of data frames, and then we can merge them together. Another way to do this is using list comprehension. Remember, we learned about list comprehension before in talking about for loops. And they're just really a compact way of writing a for loop in a single line of code. They do actually execute a bit faster than a normal for loop, so there is some efficiency advantage, especially if you had a lot of files. And they're just kind of elegant. So I will demonstrate here, df_list equals square bracket, which basically means the output of this is going to be stored in a list. We don't have to define our empty list first and then run a for loop. We basically say df_list equals and fill the list with the contents of the list comprehension. So pd.read_csv f for f in file names. So we'd already defined file names based on our glob. Do that, and then just confirm that df_list contains what we want it to. And indeed, again, it's a list of pandas data frames. So the list comprehension or the for loop method are both valid. List comprehension is a little more elegant, a little more Pythonic, a little more efficient, but both can get the job done. All right, so now we have a list of data frames and we're going to combine them. So the way we do that is with the pd.concat function. So I'm going to say df, my data frame, is equal to, so the output is going to be assigned to a new data frame called df, pd.concat df_list. So we're going to take all of the pandas data frames in that list and concatenate them, which basically means stack them one on top of each other. So right now, this list, the different data frames are separated by commas. They're totally sort of freestanding data frames, but effectively what we're going to get is one data frame with a participant ID column, a trial column, and an RT column, and 30 rows. Okay, so I'm going to run that, and then I can confirm it worked with the .sample method for data frames. So I'm going to ask for a random sample of 8 rows from the data frame that I just created. There we go. So you can see that participant ID, all the different participants are represented in our random sample of rows, different trial numbers, and different reaction times. Okay, so we've successfully combined things into a single pandas data frame. Now you might ask why we do this in 2 steps. So why do we build a list of data frames and then run pd_concat? As we're running the for loop or the list comprehension and reading in those data frames, why don't we just say, okay, start with, say, an empty data frame and then concatenate each new file that we read into that data frame. You can do this. The problem is that just the way pandas is written, when you run a concat command, there's some computational overhead in terms of it creating space in memory to store the data frame you're creating and doing some checks for sort of consistency and the data types in different cells and this sort of thing. And that takes time and it takes up memory. So if you're concatenating each incoming file in a for loop to a pandas data frame, it actually runs more slowly than the approach that we're using. And this just gets worse the more files you have. So if you have 100 files, you're going to find that building up a list of data frames and then concatenating them can be orders of magnitude faster. And I'm talking, I've worked with data sets where, I was initially trying to concatenate as I was reading, and the loop, took in some cases 10 or even 20 minutes to run. And it took a few seconds to run when I used the build a list first and then concatenate. So it's a really significant time savings that you'll get by doing it this way. All right, so the next thing we want to do is set the index column. Remember, that's the labels for the rows. In this experiment, we have individual participants as kind of what you might call our units of observation. So we have repeated measures, repeated trials of reaction time measurements that we took from each participant. And it makes sense to organize our data by participant. So make participant ID the index column. So we can do that by saying df equals df.set_index. And this syntax is important. So we can't just run df.setIndex. We need to actually assign the output of that back into df, or it'll sort of run the command, but it won't actually change df. So df equals df.setIndex, and then just the name of the column, participant ID, that we want as the index. And again, I'm just going to run that df.sample with 8 samples to confirm that it worked. And indeed now the participant ID column header or label isn't up above, you can see it was on kind of the same row, the column label row in this data frame, same as trial and RT. Now it's moved down because it's an index label, and now all the participant IDs are boldface, which means they are now the indexes for these rows. Okay, so this brings us to the end of the lesson, and now we have a couple of short exercises. As always, pause the video, try these on your own, and then unpause the video, and I'll go through the answers with you. So the first one is just sort of a thought question around the glob command and patterns. So the question is, which of these files is not matched by the expression glob.glob data /as *CSV? And all of our files are the same, except one is Africa, one's Americas, and one is Asia. So the correct answer is Asia is the only file that's actually matched by that, because it has the two characters AS together, followed by some other characters, so that's a star after, and preceded by the gapminder _GDP_, which is that star before the AS. You might have thought Americas would also match because it has an A and an S, Africa doesn't. But when we have this format of star AS star, that means anything followed by A, then S right after it, then another star. If we wanted to match anything followed by A, followed by anything followed by S, we'd have to write something like glob.glob parentheses data /star A star S star.csv. And when we do that, you see that actually matches 3 different files in the folder, all of the ones that have an A, and then sometime after the A, an S in the file name. And finally, we have an exercise on globbing files. And for this one, I admit I ninja changed the last exercise, so the video cut looks a little weird, but we're going with this new one because I like it better. Okay, so our task is to fill in the blanks so that the code below does the following. We want to find all of the CSV files in the data folder that contain GDP data. We want to read those files in using a for loop, concatenate the data files into a single Pandas data frame, and then print out the first 10 lines of the final combined data frame. So this is really just things that we did up above, just a chance to put them into practice. And just as a word of warning, the gapminder data files contain GDP data, but there are some gapminder data files that don't contain GDP data, but you can tell that from their names. So we have some sample code to fill in the blanks, but what I'm going to do, and what I advise developing a habit of doing, is when you're working on a glob statement, so let's make sure that we run our import commands. When you're working on a glob statement, don't assume it works, run it on its own first and look at the output and make sure it's what you want. So I'm just going to run glob.glob, and everything's in the data folder, / and then, well, it says we want all the CSV files that contain GDP data. So let's start with just star.csv and see what CSV files are in there. So we have gapminder all, gapminder GDP, S1 CSV life expectancy years, gapminder GDP, gapminder life expectancy. So you can see some of the files say gapminder and GDP and in CSV, but then there's some other ones that don't. So what we want to do is build something that selects only the ones that are gapminder GDP. So gapminder _GDP star.csv. And that CSV is important because there may be other files in there that don't end in .csv. Do that. Okay, now we're consistently getting just the gapminder _GDP data sets. So that's what we want to assign to the variable data files. So glob.glob, and I'll just copy my text from up above. There we go. dflist equals empty list. That's our accumulator list, where we're going to store our pandas data frames as we read them in, so we don't need to change that line. And then we have a for loop. So for what? Well, this is just our loop variable, so it doesn't really matter. We're going to call it f, because that's the first letter in files, for f in, and we want to go through the list of data files. So we type that. And then inside the body of our for loop, what we have is dflist dot something pd read csvf. So dflist dot something, we want a list method, and above we saw that what we're doing is we're appending each data frame to our list of data frames as we go. Okay, and then the next line is just a white space line, and then we're out of the body of the loop with df equals, and this is where we want to concatenate all of the data frames in that list to a single pandas data frame with pd.concat df list. And then to view the first 10 lines of a data frame, we use df.head. There we go. We see the first 10 lines in the data frame. The next challenge was to rewrite the code above, but using list comprehension rather than a for loop and only 2 lines of code total, not including the import commands and printing the head. So let's take these, copy and paste down below. And okay, to use list comprehension, we don't need to define an empty list and have a for loop. We can just say dflist equals, we still want, so inside that for loop, we want pd.read underscore csvf for f in data files. Okay. So now, not including the head command, we still have 3 lines of code. But let's make sure it works before we try and shorten it anymore. Yep, that works. Okay, so in these challenges, when you're told to reduce the number of lines of code, you have to figure out how to combine, starting with 2 pairs of, or 2 lines into 1 line. So one thing we can do is look, glob.glob is being assigned to data files. The only reason we have that variable, that list data files, is to use it once inside dflist. So more efficiently, we could actually take that bit of code and replace data files in our list comprehension, and then we get rid of that line where we're assigning it to the data files variable, only to use that variable once in the next line of code. Sometimes you're going to be reusing variables, so maybe assigning it to a variable first made sense, but sometimes this reduction is more efficient and reduces the length of the code. Run that. Okay. So that's our solution with 2 lines of code, not including df head. I'm going to copy that. Actually, I'll copy the whole thing down below. So how do we get this down to 1 line of code? Well, again, look at what we're doing. We're assigning the result of the list comprehension to a variable called dflist. Then we only ever use that variable once, dflist, in pd.concat. So what if we take that out and substitute it for dflist in the pd.concat command? 1 line of code, run it, and it still works fine. So there you have it. Now, in some cases, this code might be considered less, it's more elegant in the sense that you're doing something that before, let's see, in our first solution took 1, 2, 3, 4, 5 lines of code. We've reduced that to 1. So that's efficient and elegant in a sense, but it's also a very dense line of code, and there's a lot going on. So something like this with list comprehension or even the for loop is a little more transparent and maybe a little more readable. So there's a trade-off there. Again, when you're doing coding, there's usually a lot of different ways you can do the same thing. And the question is what makes most sense to you, what's most efficient, it's going to run fastest, and also most transparent to your future self or other people looking at your code. Anyway, there you have it. To summarize, we can use a for loop to process files given a list of their names. To get the list of their file names, we can use glob.glob to find sets of files that match a specific pattern. And we can use things like the star wildcard to match any number of characters, or the question mark to match a single character. List comprehension can be used to replace a for loop, resulting in more compact and efficient code. Naming your files in a consistent manner is just as important in data science as writing the code to read them, because if your data files are named inconsistently, then writing the code is going to be a lot harder. And finally, when you want to combine multiple files into one Pandas data frame, remember that the best practice is to read each one into a list of data frames, then run pd.concat only once on the result. Thanks for watching, and we'll see you next time.